Hello friends, I am Dr. Sangeeta Patil, Assistant Professor in the Department of Electrical and Electronics Engineering, MIT School of Computing, MIT ADT University. Welcome you all for a course on basics of transformer. Let us start the lecture. So what is autotransformer? A autotransformer is a transformer having only one winding which is wounded on the laminated magnetic core, and part of this winding is common to both primary and secondary circuit. As an ordinary two winding transformer, this auto transformer or single winding transformer, it can also be used as a step down or step up transformer. So here I have drawn two figures. In figure number A, my auto transformer is step down transformer, and in figure number B, my auto transformer is step up auto transformer. So in figure A, the winding part, the AC forms the primary and its portion of the same winding BC forms the secondary. So this much portion of your winding forms secondary, and this whole portion will forms the primary of the auto transformer. On other hand, in figure number B, the winding AC forms the secondary, whereas its portion, small portion BC forms the primary. So the performance of the auto transformer is governed by the same fundamental consideration that I have taught you related to the two winding transformer. So in case of auto transformer also, if we neglect the losses and leakage reactance and the magnetizing current, we can write down in auto transformer also my V2 upon V1 equals to E2 upon E1 equals to N2 upon N1 equals to I1 upon I2, which is called as transformation ratio K of the transformer. What assumption we have done? Here we have neglected the losses. We have neglected the leakage reactance. And we have assumed that magnetizing current is very small or approximately equals to 0 or negligible, or we can say very negligible, and that's why my V2 upon V1 equals to E2 upon E1 equals to N2 upon N1 equals to I1 upon I2, which is nothing but the transformation ratio K. So students, in two winding transformer there are two windings. So copper required for wounding those two winding is more. As in case of your auto transformer, you can see the transformer has only one winding, right? So as the transformer has only one winding and it can behave as a step down or step up transformer, the copper required is less. So there is saving in the copper. So with the help of the mathematical explanation, I will tell you how there will be the saving in the copper in case of the auto transformer. So if I consider the same capacity, that is same output and the same voltage ratio, the auto transformer requires less copper than that of your conventional two winding transformer that we have seen in the previous lectures. So this can be easily verified as follows. So let us consider first of all the step down auto transformer. So before considering the step down auto transformer, for any winding, the cross section of conductor of the winding is proportional to current carried. If the cross sectional is more, means that winding may carry more current. If cross sectional is less, means resistance is more, so it will carry the less current, right? So cross section of any conductor is proportional to the current. That I can write down. Similarly, I can write down total length of conductor. I can write down total length of conductor is proportional to number of turns. Number of turns n. Let's say it as a n. Hence, what is area of cross section into length? It is nothing but the volume. So I can write down volume of copper or weight of copper is proportional to N into I. Is proportional to N into I. Because my volume is nothing but area into length. My area is proportional to current and my length is proportional to number of turns. Hence the weight of the transformer or volume of the transformer copper or the transformer winding copper, that is proportional to N into I. So let us use this relationship to compare the requirement of copper in case of ordinary two winding transformer and the auto transformer performing the same duty of stepping up or stepping down the voltage and having same capacity and same voltage ratio. So first of all, I will write down here the two winding transformer. So I will write down here about the two winding transformer first. So in two winding transformer, I will write down now weight of copper for primary winding is proportional to N1 into I1, where N1 is the number of turns of primary winding and I1 is the full load rated current of your primary winding. Similarly, I can write down weight of copper for secondary winding is proportional to N2 into I2, where N2 are the number of turns of secondary winding and I2 is the full load rated current of your secondary winding. Therefore, total weight of copper required for two winding transformer is proportional to N1 I1 plus N2 I2. Let us give this equation as equation number 1. Afterward, we will compare the weight of two winding transformer with the single winding transformer. So let us this equation as equation number 1. Now I will consider step down auto transformer first. I will consider step down auto transformer. So step down means my primary winding has more number of turns, whereas my secondary winding has less number of turns, right? So I have considered the step down transformer here. So the current distribution in the winding is shown in my figure. So section AB, this section has how many number of turns? This section have total N1 minus N2 turns, because N1 are the number of turns of whole winding, right? And N2 are the number of turns of your secondary winding across which you have connected the load. So what is the number of turns of remaining portion, that is AB? It is N1 minus N2. So these N1 minus N2 turns carries current I1. Since this is a step down transformer, my I2 is greater than I1, as this is a step down transformer. Means my secondary voltage is less, so secondary current is more than that of your primary current. The section BC is having N2 turns, right? And what is the current in section BC? It is nothing but I2 minus I1, because my current I2 is known to me, I1 is known to you. Here in this branch my I1 should get return. So what is current in this branch? For that purpose I have applied the Kirchhoff's current law here. This is current I1, this I2 is coming here. So out of I2, I1 is going toward the supply. So remaining current will go in the upward side. So that is I2 minus I1, right? Hence, for this step down auto transformer, I can write down weight of copper. Wait for a minute. So I can write down weight of copper for section AB. For section AB is proportional to, what is number of turns of section AB? It is N1 minus N2. So N1 minus N2 into what is current in the section AB? It is I1, right? Similarly, weight of copper for section BC, it is proportional to what? The number of turns of section BC, N2, into what is the current? I2 minus I1. So the total weight required. So the total weight of copper in step down auto transformer is proportional to N1 minus N2 into I1 plus N2 into I2 minus I1. Just I have added both. Okay. So let us give this equation as equation number 2. Equation number 2. From equation 1 and 2. From equation 1 and 2. What is equation? Total weight of copper required for two winding transformer is proportional to N1 I1 plus N2 I2. And what is the total weight of copper required in step down auto transformer is proportional to N1 minus N2 into I1 plus N2 into I2 minus I1. Hence, from equation 1 and 2, I can write down weight of copper. Simply I will write down Cu here now. In step down auto transformer, upon weight of copper in two winding transformer equals to what? It is nothing but equation 2 divided by 1. So N1 minus N2 into I1 plus N2 into I2 minus I1 divided by what? Weight of the copper in two winding transformer, that is N1 I1 plus N2 I2. N2 I2. So if we simplify this, I can write down this as, now see, N1 into I1 minus N2 into I1, right? So N1, sorry, I will simplify this first of all. N1 I1 minus N2 I1 plus N2 I2 minus N2 I1 divided by N1 I1 plus N2 I2. So simply if I add these two terms, first of all, so this will be this term plus this term divided by this term. So I will get it as 1. So I can write down this as 1 minus 2 N2 I1. So this plus this means 2 N2 I1 divided by denominator remains same, that is N1 I1 plus N2 I2, right? So if I divide the numerator and denominator by N2 I1, what I will get? 1 minus. If I divide these terms numerator and denominator by N2 I1, on the numerator side I will get 2. On the denominator side, N1 I1 divided by N2 I1, right? So my I1 will get cancelled. I will get here N1 upon N2 plus N2 I2 divided by N2 I1. So N2 will get cancelled. What I will get? I2 divided by I1, right? So I can write down this as 1 minus 2 upon 1 upon K plus 1 upon K. So I will write down this as 1 upon 2 into 2 divided by 2 by K. So my 2 will get cancelled. I will get this as 1 minus K. 1 minus K. So what is on the left hand side of this equation? I have written weight of copper. Wait, I will take that. What I will get on this side, it is nothing but weight of copper upon weight of copper in step down auto transformer upon weight of copper in two winding transformer equals to 1 minus K, equals to 1 minus K. So students, I can write down here, therefore saving of copper in step down auto transformer, step down auto transformer equals to weight of copper in two winding transformer minus weight of copper in step down auto transformer. What is the weight of copper in two winding transformer? That I will write down as it is. Weight of copper in two winding transformer minus. What is weight of copper in step down transformer? I can write down it as 1 minus K into weight of copper in two winding transformer. So I will replace this term as 1 minus K into weight of copper in two winding transformer. So I can write down this as K into weight of copper in two winding transformer. Weight of copper in two winding transformer, I will take common. So it will be 1 minus 1 plus K. So 1 will get cancelled and I will get K into weight of copper in two winding transformer. So that this is the saving in copper. This will be the saving in copper. What is K? K is nothing but V2 upon V1, right? So this auto transformer, which type of auto transformer we have considered? Step down transformer. Step down transformer, in step down transformer, my V2 is less than V1. So my K is less than 1. So if my K is less than 1, it means there is considerable saving in copper which is required in step down auto transformer, right? Hence, we have proved that there will be considerable saving in the copper if I use the single winding transformer as a step down auto transformer. Similarly, we can go for the step up auto transformer. So let us consider the step up auto transformer here. In this transformer, the current distribution winding is shown in this figure. In this case, my section AB means this section. My section AB is having N2 minus N1 turns. Total winding turns, as my this is step up transformer, so secondary has more number of turns, that I have considered as a N2, and primary has number of turns N1. So what is the section AB turns? N2 minus N1. And what is the current in the secondary? That is I2. So my section AB carry current I2 and number of turns of my section AB is nothing but N2 minus N1. Right? So the current I1 and I2 being in phase opposition, and I1 is now my I1 is greater than that of I2. Right? My I1 is greater than that of I2. Why? Because this is a step up transformer. Means voltage, secondary voltage is more. So secondary current is less and my primary current will be more. Right? So as my I1 and I2 are being in phase opposition and I1 is greater than I2, my section BC having N1 turns and it carries the resultant current I1 minus I2. So this is I1 which is known, this is I2 which is known, this I2 is coming up to this point, out of which I1 is going towards the primary. So what should be this current? This current should be, apply Kirchhoff's current law here, this current should be I1 minus I2. So again we will start for the derivation. So let us consider what is the, first of all I will consider the section AB. So the weight of copper for section AB, this one for section AB is proportional to what? What is the section AB turns? Those are nothing but N2 minus N1. And what is the section AB current? That is I2. Similarly, I can write down weight of copper for section BC is proportional to, what is the number of turns of section BC? Those are N1. What is the current? I1 minus I2. Therefore, I can write down total weight of copper is proportional to, in which transformer? In step up auto transformer, it is proportional to N2 minus N1 into I2 plus N1 into I1 minus I2. Let us give this equation as equation number 3. Right? Now from equation number 1, this equation number 1, this is the total weight of copper required for 2 winding transformer. From equation 1 and 2, I can write down, sorry, not 1 and 2, 1 and 3, I can write down weight of copper in step up auto transformer divided by weight of copper in 2 winding transformer. That will be equal to N2 minus N1 into I2 plus N1 into I1 minus I2 divided by, what is the weight of copper in 2 winding transformer? Copper weight in primary plus copper weight in secondary. Students, you have to keep in mind that in auto transformer only number of turns and current is getting changing, because same winding is used as a primary as well as secondary, right? So these windings are magnetically coupled on the same magnetic core. I will tell you that again. First of all, we'll complete these derivations. What you will get here, N1 I1. I will get here N1 I1 plus N2 I2 minus 2N1 I2 divided by N1 I1 plus N2 I2. So that will be, again I can write down 1 minus 2N1 I2 divided by N1 I1 plus N2 I2. Right? So if I divide the numerator and denominator of this side by N1 I2, what I will get? 2 divided by N1 I1 upon N1 I2. I will get this as I1 upon I2. Right? Plus N2 I2 divided by N1 I2. I2 will get cancelled. This you will get as N2 upon N1. N2 upon N1. But students, what is N2 upon N1 and I1 upon I2? It is K, right? So here I will get 1 minus 2 upon 2K. So my 2 will get cancelled, right? My 2 will get cancelled. I will write down this as 1 minus 1 upon K. 1 minus 1 upon K. So I can write down, similar as in previous case, I can write down saving of copper in step up auto transformer equals to 1 upon K into weight of copper in 2 winding transformer. In between step I have kept for you people, because I have explained in the previous section, saving in the copper is nothing but what formula we have written? Weight of copper in 2 winding transformer minus weight of copper in the step down transformer. right? So weight of copper in two winding transformer, as it is we have to write down, and weight of the copper in step up auto transformer is nothing but 1 minus 1 upon k into weight of copper in two winding transformer. If you solve that, you will get this final equation, right? So this will be the saving in the copper. Let this equation as equation number 4. So students, what is K for step up transformer? What is K? K is nothing but V2 upon V1. In my step up transformer, what is value of V2? It is greater than V1, right? It is greater than V1. So my K will be what? K will be more than that of your 1, right? So K is greater than 1. So 1 divided by value which is greater than 1, it is this term will be less than that of 1. So there will be considerable saving in the copper if I use a auto transformer or single winding transformer as a step up transformer. So from this equation and the previous equation that I have shown here, this equation, what you can conclude? We can conclude that nearer is the ratio of the transformation to the unity, greater will be the saving in the copper. Greater will be the saving in the copper. So what are the advantages of? Let us see. From the derivation, we will conclude what are the advantages of your auto transformer. So what is the first advantage? Weight of copper required for auto transformer is always less than that of your conventional two winding transformer that we have seen in the previous lecture. So as the weight of copper required is less, there will be this transformer will be comparatively cheaper than that of your two winding transformer. The saving of copper is increased as the transformation ratio approaches towards the unity. Also, the resistance and leakage reactance of auto transformer will be less because only one winding we are using, right? So the leakage reactance and resistance of this transformer is less because of only one winding. So the regulation will be better. First advantage, saving in copper. Second advantage, as resistance and leakage reactance is less, regulation is better. Also, I square R losses will be less because only one winding, so that winding resistance is very small, so I square R loss will be less, so efficiency will be more. It will get increased, right, comparative to your two winding transformer. In two winding transformer, we will require more copper due to resistance and leakage reactance of primary and secondary winding. Regulation will be poor. Due to the resistance of both winding, I square R loss will be more and efficiency will be less. But these are not, these are very less. Saving in the copper is more, regulation is better, and I square R losses decreases, so efficiency increases in case of your auto transformer. Then what is the disadvantage of auto transformer? Why we are not using auto transformer everywhere? Because in case of an auto transformer, there is always a risk of serious electric shock, particularly when it is used in the high voltage circuits. This is because the low voltage side and high voltage side, they are magnetically coupled, but they are not electrically separated as in case of your two winding transformer. In your two winding transformer, both windings are electrically separated and magnetically coupled, right? Here, both windings are magnetically coupled as well as not electrically separated, or they are one winding is only forming the part of primary as well as secondary. So there is higher risk of serious electric shock when it is used in the high voltage circuits. Then why we are using auto transformers? Then we are using auto transformers for lower voltage rating. So what are the applications of auto transformer? Auto transformers are normally used for starting synchronous motors and squirrel cage induction motor. Means first application, starting of the motors. Which motors? Synchronous motors and induction motors, squirrel cage induction motors, right? Again, auto transformer is used for interconnecting the AC systems having roughly the same operating voltage. Your auto transformer can also be used as a booster to raise the voltage in AC feeders. Your auto transformer can also be used as a furnace transformer for getting suitable supply voltage, and it is also used as a variac, which is very important applications. My auto transformer can be used as a variac for getting continuously variable AC supply voltage. So this is the most common application of your auto transformer. Students, we know that your ordinary rheostat can be used as a potential divider for continuously getting the variable AC voltage, right? But it is useful only for stepping down the voltage, right? On other hand, your auto transformer, even though costlier, has some distinct advantage that it can step up as well as step down the voltage, right? And it has negligible loss and more efficiency. So this is the figure that I have drawn for the auto transformer, which is used as a single phase variac, right? So figure shows the constructional details of your single phase variac. So it has the one wind. This is one toroidal core. This one is one toroidal core, circular ring. So this is a toroidal core on which I have wounded the winding, right? So the input voltage V1 is connected, or applied between the terminal A and B, and a continuously variable, this voltage is variable. Sorry, I have forgot here to write down the word variable. This is the continuously variable output voltage V2 from 0 to about 120% of input voltage that can be obtained across these output terminals between D and E. How to obtain? This is one sliding contact S, which is continuously moving along with the surface of the winding. So your voltage at the output will get vary. Such variac are many times used in dimming the light in the theaters, for dimming the lights in the theaters. Hence, such type of auto transformer are also called as the dimmer stat. So what is the use of auto transformer? Use of auto transformer to get the variable AC voltage. So by moving this sliding con, this is one stopper here. Up to this point only we can vary the voltage. Beyond 120% we cannot go for it, right? So this is the sliding contact which is continuously moving along with the surface of the winding, so that number of turns are varying. As number of turns are varying, my output voltage is varying. So this is the one of the fantastic application of your auto transformer. So in this lecture we have covered the auto transformer concept. So now in my next two lectures I will take some problems related to the calculation of efficiency, regulation, auto transformer, all day efficiency and all. So here I will stop. Thank you students. If you like this lecture, please don't forget to like, share and subscribe my YouTube channel.